This is a video on using arcsecant substitution. The question is to integrate the square root of x squared minus 1 dx. The technique I will use is the trig formula secant squared of x minus 1 is equal to tangent squared of x. Notice I have an x squared minus 1, so if I let x equal secant of theta, then this square root will turn out very nice. So in particular, if x is secant theta, I take a derivative of secant theta, I get dx equals secant theta times tangent theta, d theta, and this square root of x squared minus 1 is the same as the square root of secant squared theta minus 1. And now I can use the identity, secant squared theta minus 1 is the tangent squared theta, and of course the root of a square is just itself, and I get that the square root of x squared minus 1 is equal to tangent of theta. Now I can substitute all of this into the integral. And what I get is the integral of the tangent theta that comes from the square root times the secant theta, tangent theta, d theta that comes from dx. Okay, the trick on this integral is tangent theta times tangent theta is tangent squared theta. And tangent squared theta is secant squared theta minus 1 from this identity. I can multiply the secant squared theta minus 1 through the secant theta, and I get a secant cubed theta d theta minus a secant of theta d theta. For the secant cubed of theta, I'm going to use integration by parts. And what I get is u is secant theta, dv is secant squared theta d theta, because that has an easy integral. The integral of secant squared theta is the tangent of theta, and the derivative of secant of theta is secant of theta tangent theta d theta. So putting this together and using the integration by parts formula, I get uv, which is secant theta tangent theta, minus the integral of v du, which is the integral of tangent theta times secant theta tangent theta d theta, and then I integrated secant of theta d theta. Remember, that's the natural log of the secant plus the tangent. So notice I now have this integral, which is the same as the integral I started with. Because it has a minus sign, I can add that integral to both sides. What I get is 2 of those integrals, or 2 times the integral of the tangent theta, secant theta, tangent theta, d theta, is equal to what's left over, secant theta, tangent theta, minus natural log of the secant theta plus tangent theta. Now I just divide by 2. And what I get after substituting, notice that the secant theta is x, and the tangent theta was our square root of x squared minus 1. So I divide by 2, and I substitute in, and I finally get 1/2 times secant theta was x, times tangent theta was square root of x squared minus 1, minus the natural log of the secant of theta, which was x in absolute values, and then plus the tangent of theta, which was x squared minus 1 under the square root, and then finally plus a constant, and I'm done with the problem.